The next services I'm going to discuss in this chapter on implementing elasticity are Simple Storage Service, or S3 for short, Glacier, and CloudFront, which provides scalable storage solutions for your applications. S3 was actually mentioned previously when discussing EBS snapshots, as this is where EBS snapshots are stored, but I will go into more detail here. First of all, let's take a general look at the scalable storage options AWS provides. Block Instant Storage, or EBS, is something I've covered, so you already know about this one. Object storage can be accomplished using S3, Glacier, or CloudFront, and we're going to talk about these in more detail in this section. The AWS Storage Gateway is a service that allows you to connect your on-premise storage resources with cloud-based storage, providing a way to integrate an organization's local IT environment with AWS's storage infrastructure. This can allow your organization to sync data to AWS's scalable and cost-effective storage. Amazon RDS is also something previously discussed and should be familiar to you at this point. Amazon also offers a NoSQL database option called DynamoDB, which is the topic of a section later in this course. You'll learn more about that then. There is also an in-memory distributed cache option called Elasticache. If you are familiar with Memcached, then you are already familiar with Elasticache. And then last on this list is CloudFront again, which offers content caching. Let's dive into S3 and learn more about this service that will invariably play a role in your cloud application architecture. So S3 is an object store. In an object store, objects are stored in a flat organization, which are referred to as buckets in S3, and retrieved by a unique identifier called keys in S3. Now, keys can be any string and can be constructed to mimic hierarchical attributes, meaning that you can sort of make it look like a directory structure, but it should not be confused with one. This is typically contrasted with a traditional file system, where files are organized in a directory hierarchy and house a central repository of metadata about the files which can be used to search on and retrieve the information. Minimizing the metadata management overhead in object storage allows for almost endless scalability and very fast object retrieval. Of course, the features you get with object storage are often limited when compared to file storage. For example, S3 does not offer the ability to search across all objects in storage. S3 is built to be incredibly durable. This is achieved by redundantly storing your objects on multiple devices across multiple availability zones in an Amazon S3 region. Now, if your storage needs do not require these extremely high levels, you can opt for reduced redundancy storage, sometimes referred to as RRS. This is an option in S3 which reduces your storage costs. You can use this reduced redundancy option for objects that you can easily reproduce in the event of a failure. So some good examples might be the generation of thumbnails or different image sizes from an original, or different video encodings from an original source. S3 provides, in theory, unlimited storage capacity. It will scale and grow as your storage needs demand. There is no defined limit to the amount of content you can store. There is, however, a 5 terabyte limit on the size each object can be, but not a limit on the number of these objects you can store. You can access these objects via REST or SOAP API protocols, which makes it easy to implement in most any application. Now, one thing to note about the way S3 works is that S3 object storage works on an eventual consistency model. While your objects stored in S3 are highly available and highly durable, the data consistency is achieved only eventually. I mentioned that the availability and durability is achieved by replicating the data across devices both within an availability zone and across availability zones. Whenever you update an object, you have to wait until the change is propagated to all of the replicas before requests will return the latest version. So, for example, this could occur when you delete an object. It may take some time to propagate to all replicas, and therefore there is a brief period of time where objects could still be returned after a delete request has been made. So, while object storage is a great fit for all of your data that doesn't change much, like backups and archives, log files, videos, images, and audio files, etc., This eventual consistency can make object storage unsuitable for data that changes frequently. Another object storage option available to you within AWS is Amazon Glacier, perhaps named because this is something you might use to freeze your data. The Glacier storage is like an extension of S3, but is suitable for archiving your data that will be accessed very infrequently and where retrieval time of several hours is acceptable. You get the same 11 nines of durability, just as you do with S3, but your storage costs are much less. And then you pay per archive and per restore requests, but these are also at a very low cost. Now you manage your objects in Glacier through S3. You don't associate an object with Glacier storage directly as you upload it. Rather, you can transition existing Amazon S3 objects to Glacier when the data is ready for archiving. Now on to CloudFront. Amazon CloudFront provides a content delivery service for your assets and is built to work seamlessly with S3, though using S3 is not a requirement for taking advantage of CloudFront. If you are familiar with content delivery networks, or sometimes called CDNs, such as Akamai or Windows Azure, then you are familiar with what CloudFront does. The idea is that it uses a globally distributed network of edge locations to minimize latency in delivering your content to the end user. Using CloudFront is very straightforward. To start using CloudFront with your web application assets, you store the original versions of your files on one or more origin servers. An origin server is the location of the definitive version of an object. Origin servers could be other Amazon Web Services, such as an Amazon S3 bucket, an Amazon EC2 instance, or an Elastic Load Balancer, or your own origin server. You then create a distribution to register your origin servers with Amazon CloudFront. You can do this through the AWS Management Console. The new distribution you created has an associated domain name, and you use this domain name in your applications to access the objects you are storing. When end users request an object using this domain name, they are automatically routed to the nearest edge location for high-performance delivery of your content. And as is the case with almost all AWS services, you pay only for the data transfer and requests that you actually use. S3, Glacier, and CloudFront. These are your object storage options in AWS and are, at least in theory, infinitely scalable and will forever expand to accommodate your ever-growing needs to store your application assets. So, implementing elasticity, rule number 3. Take advantage of the available storage options in AWS to improve scalability, availability, durability, and performance of storing and accessing your application assets.